Question 3 essay. Mammals have a double circulatory system, fish have a single circulatory system, and this is the circulation in a human, which is of course a mammal. Systemic, as to all of the body's systems apart from the lungs, and that's the lung circulation on the right. What jobs have we got to do? We need to use the information in the graph. Okay, so we're going to have to quote some figures and so on. Explain the pressure changes in these two areas. So we're going to compare those pressure changes on that line to those pressure changes on that line, say why they go up, down, or relative to each other. Then we've got another job. We've got comparing the mammal to the fish, which is the double to the single. So our plan, our quick plan for this will be, we're going to talk about mammal double circulation in terms of systemic and pulmonary. So there's my two big areas. I'm going to put mammal double versus fish single. That's another area. So those are my three areas that we're going to look at. I'm not going to write the essay. Let's just have a look at some of those areas. So mammal, systemic. Let's see what we can see. So we're going to say, notice that the pressure is higher. So I'm going to talk about the high pressure. And we want, values from the graph. How this happens, what's contracting, where this is happening, why do we need high pressure? We can, so these up and down, why is there a minimum at the start? Why doesn't it go down to 0? So not to 0 there. What's maintaining the pressure? So blood vessels maintain the pressure. So how do they do that? What else can we say? So then why does it decrease? So why does the pressure decrease? And we could talk about the capillaries and veins. What's happening? Pressure in the capillaries, pressure in the capillaries and veins. How's that maintained, or what do we know about that? So pulmonary, we don't particularly need all of this stuff again if it's the same, but we can go, how is the pressure generated? for example, where, so talking about which side of the heart, where in the heart. Again, we can talk about values from the graph compared to the systemic, and then really, why is it lower? So why is that lower than the systemic? What problems is that overcoming? And then we've got the benefits of the double versus the single. So double circulation, more efficient than single circulation. So we could describe both circulations, so we know what we're talking about. The examiner can see that we know it. If you talk about the fish, so how the pressure is lost in the fish. So in that single circulation, when you draw the diagram, how the pressure is lost, we can relate that into speed of blood flow. And then finally, why double is needed in mammals. And one of the earlier questions dealt with this, mammals versus fish. So why do the mammals need a more efficient system to deliver oxygen? So that's your general plan. I might do a more detailed model answer.